Our next fun sheet will be on acids and bases. This particular standard is 9.12 and says that you need to be able to identify the basic properties of acids and bases. So, there's a couple of things, of course, that we need to know up front, and that would be the definition of what an acid is. So for the definition of an acid, we're looking at something that we are going to talk a lot more about later, but it says that it produces positive hydrogen ions. And what that actually looks like is this, and that would be in a solution. An example of this would be orange juice, and there's lots of other things that we will be doing in a lab, and you will be identifying whether it's an acid or base or a neutral substance for that matter. Now, I want you to add after this example that most acids react with metals. This is the thing that you need to add. Most acids react with metals. And so we'll show a demonstration of that when we go to lab and what that actually will look like. For the definition of a base, it is something that is going to produce negative hydroxide ions. And what that looks like is an OH negative in a solution. So that's actually what we are recording whenever things change colors. It's recording how much hydrogen ions or how many hydroxide ions there are. An example of this would be coffee. And once again, we'll test some other bases and see what do they end up being as well. For a neutral substance, this is not that difficult. Basically, what you have here is something that is neither an acid or a base. And whenever we're looking at something that's neutral, the pH of that will equal 7. And so that's not a typo. It should be a lowercase p, capital H. That's how you write pH. We'll talk more about pH here in just a second. Okay, so let's go ahead and talk about pH. pH is actually a specific number, and if you look at the scale down below, it is going to range from 0 to 14. And this basically is going to determine the strength or weakness in that matter. It can be really strong or it can be really weak of an acid or base. So if you look at this picture down below, what we're actually looking at as you are, 7 remembers being neutral. And so the further away you get from 7, the stronger the acid becomes or the stronger the base becomes. Okay, right now I want you to go back up and look at these different vocabulary words, and I want you to put a circle around the word acid if your last name starts with A through F. You're circling acids. If your last name is G through M, you're going to put a square around the word base. And if your last name begins with an N through Z, you're going to put a heart around the word neutral. Now, the last thing that we need to know for acids and bases is how are we going to test to determine whether it's an acid or a base. And this is called an indicator. So an indicator is a substance that changes colors. If an acid, or I should say when an acid or base is added to it. An example of this is what you see down here below, and that would be litmus paper. Okay, we're actually going to use a different indicator in the lab, and it will be cabbage juice. And so what you're going to get with cabbage juice is a wide range of colors. Litmus paper will only tell you whether it's an acid or whether it's a base. And remember, it has to change color. So if you don't see any color change, that means you have a neutral substance, no matter what kind of indicator you're using. Litmus paper will either turn, if you remember, and we'll talk about this here in a second, it will either turn red or blue if you use the opposite color. With cabbage juice, it will change a variety of colors, and it's actually a better indicator of an acid or a base because it will tell you how weak it is or how strong it is. And we'll talk more about that when we actually go to the lab and are testing our acids and bases. So now we have the definitions behind us, and we have a little bit of better, hopefully, background knowledge of that. We need to look at what the properties are. And if you think of some of the common acids and bases that we eat or drink, a lot of these will actually help you to remember. And there's something else, too, that we will talk about on how to remember the different properties of these. So, acids are going to taste sour. If you've ever eaten a lemon or any kind of a citric fruit, it typically is going to have that sour tendency to it. Bases, on the other hand, are going to taste bitter. And anything, if you've ever actually accidentally gotten soap in your mouth, you've tasted that bitterness. I gave you the example of coffee earlier and coffee beans. If you don't add anything to it and you just drink coffee, it has a bitter taste to it. When we talk about how acids feel, we're going to say that it feels watery. It doesn't feel much different than water. We don't want you to go out and taste these. We don't want you to go out and feel these unless you actually know what it is. In the lab, of course, we're going to tell you not to do that. But if we were to allow you to feel those, it would feel watery. On the other hand, bases are going to feel slippery. So an example of this is if you've ever gotten soap on your hands, it has a slippery texture to it. It's not just that it's because you've added water to it. It is a base, and all bases are going to have a slippery feel to them. What is the pH value of an acid? So we said that a pH ranges anywhere from 0 to 14, and we said that a neutral substance was 7. So if we're talking about an acid, the first letter in the alphabet is A, and the first set of numbers with the pH value will be with the A. So this is the easiest way to remember it. pH value here is going to end up being less than 7. Remember, it can't be 7. 7 is neutral, so it will be anything basically between 0 and 7. Okay? pH value for that of a base. B is the second letter in the alphabet, and so if we can remember that the second set of numbers goes with the second letter in the alphabet, basically what we have is anything that is greater than 7. Remember, it can't be 7. 7 is neutral, so we're looking at anything between 7 and 14 on that pH scale. Okay, that's the easiest way that I can get you to remember that, hopefully. Now, litmus paper will turn colors if you have an acid and if you have a base. It will not turn colors if you have a neutral substance. That's important to remember on how an indicator works. If you have an acid, it will turn blue litmus paper red. Okay? It will turn it red. That's important to remember. But if you are testing for a base, here's another thing that will make it easy. It will turn red litmus blue. So remember, if it turns blue, not if it stays blue, but if it turns blue, then you have a base. And both of those words start with a B, so hopefully that will be an easy way to remember. Litmus paper that turns blue is a base. And I also forgot to mention that the word bitter starts with the letter B, and that's another way to remember that bases will also taste bitter. So, sorry I'm going back to that now. But acids and bases, do they conduct electricity? This is going to be simply a yes or no question, and the answer to do acids conduct electricity is yes. You remember we said that it was a positive ion, and because there is a charged particle here, it will conduct electricity. And the same goes for bases. Both of them will conduct electricity. So if you're just basing it off of whether they conduct electricity, you know you at least don't have a neutral substance, but you don't know whether you have an acid or base until you look at some of the other properties that they do have. And once again, bases conduct electricity because it is a negative ion. Are they corrosive? Okay, so the answer to these is, to acids, is yes, it is corrosive, and we'll talk about what corrosive means here in just a second. But if you have ever felt burning of your skin whenever you had lemon juice on it, or if it got in your eye, that is the idea of it being corrosive, okay? We'll give a more technical definition here in just a second. But most people don't think that bases can be corrosive, and they are. Both bases and acids are just as corrosive. If you have a strong base, it's very corrosive. If you have a strong acid, it is very corrosive. And on the other hand, if you have a weak acid, it is somewhat corrosive. If you have a weak base, it is somewhat corrosive. So this is where you're going to write down what corrosive actually means. You're going to put this down for note number 1. We're going to say that corrosive means to cause damage or destroy other substances. You are to write this in there for number 1. Corrosive means to cause damage or destroy other substances. We talked about chemical changes. This would be an example of a chemical change, most definitely. It can cause serious damage to your tissues, irreparable damage to your tissues and other surfaces if you were to allow those to get on there. The other note that I want us to write down here is that litmus paper doesn't change color if it is a neutral substance. Okay, I talked about this a second ago, but I want to make sure that you have it written down. So you actually have to test both red and blue, and if neither one of them turn colors, then you have a neutral substance. Okay, so now what we're going to do, because it's really difficult to do much with this, I'm going to fill in the blanks in these statements, and what you are to do is fill in the blanks with what I'm asking you to do. And then out to the right of each number, you're going to write whether it is an acid, base, or a neutral substance. Okay, so we'll fill in the blanks with the information that I want you to do, and then you can look on the other side to see whether it's an acid or a base or neutral. So number 1, the first thing that I want you to do is to write in that it turns blue litmus paper red. Okay, so you're going to answer this, you're going to look back on the front, remember, and write out to the right whether it's an acid, base, or neutral substance. Number 2, if it tastes bitter, what kind of substance is it? Number 3, if it produces positive hydrogen ions in a solution. Number 4, if the pH value is that of 7, what kind of substance do you have? Number 5, if it conducts electricity and tastes sour, what kind of substance do you have? Number 6, if it is corrosive and has a pH of 11, what type of substance do you have? Number 7, this substance has a pH value of a 4. Number 8, with this particular substance, you're going to have blue litmus paper that stays blue and red litmus paper that will stay red. Number 9, this particular substance, acid, base, or neutral, will produce negative hydroxide ions in a solution. And last here, number 10, this particular substance will taste sour if you were to taste it. And once again, we don't want you to do that in a laboratory setting. Okay, last thing I want you to do, if you look at the picture down below, all of 1 through 10, you see 2 pieces of paper, and while on your sheet they're black and white, on my screen it is in color. So number 1 on my screen, I want you to indicate whether this is an acid, base, or neutral substance based on how the litmus paper color turned. And number 2, right out to the side of it, whether this was an acid, base, or neutral based on the color that it turned as well. And this is it for Fun Sheet 9.12. And the last one for 2014, guys.